In this video, you are going to learn how to implement smooth camera zoom, controlled with the mouse wheel, and define zoom limits. Let's get started. First, we need to define all actions and their inputs in the project's input map. Go to the Project menu, found in the top menu bar, and select Project Settings. In the new window, go to the Input Map tab, and add all the actions your game requires. Godot's input system is easy to understand. The project's input map defines specific keys and buttons for each action, and actions are subsequently connected to the logic in the code. In my case, I want to add camera movement, right, left, up, and down, which will be controlled by the WASD keys. I also want camera zoom in and zoom out actions, which will be controlled by the mouse wheel. Finally, I need a zoom reset action so that I can return to the default zoom setting easily. This will be done with the mouse middle button. Now that the input map is completed, we can reference the actions and attach logic for each one in the camera script. Select the camera 2D node from the scene tree and add a script to it. We'll start by implementing the camera movement in the input method. For each action, I am checking to see whether the key was pressed. If the key was pressed, I move the camera to the corresponding direction. Done. Now let's test the camera movement and see if the inputs work. The input works, and the camera does move in the correct direction, but every time I press and hold a key, there is a delay between the first movement and the rest. This happens because our input handling code is found in the input method. The input method is called every time there is an input event, as opposed to receiving raw input. To make the movement smooth, we need to constantly check the state of the keys. To do that, simply replace the input method with the process method. This will ensure the user input is checked every frame, and not wait for input events from the system. Now it works great. I am changing some of the if statements to else if, because I want only one movement direction in each axis at a time. Next, I will define two more constants, the camera zoom speed, and the camera zoom default value. The camera zoom speed is the speed at which the camera zooms in and out, and the zoom default value will be used to reset the zoom. To check if the mouse wheel was scrolled up or down, we use the isActionJustPressed method. If the mouse wheel was scrolled, we add the camera zoom speed to the current zoom value. To implement the zoom reset logic, I check whether the middle mouse button is pressed. If it is, I set the camera zoom value to the default vector. The camera zoom works okay, but there is an annoying issue where the zoom slows down the closer I get. This problem occurs because in our current implementation, the scaling of the screen is linear, but it should be exponential. So what do? Multiply the zoom value by a factor. Instead of adding the camera speed, we will multiply the current zoom value by a percentage, determined by the camera speed. Note that for the zoom out effect, you need to divide the current zoom value by the camera speed factor. Now it works as expected. Let's set a minimum and a maximum value for our camera zoom. Define two constants that represent the minimum and maximum values for the camera zoom. In the camera zoom in action, check if the camera is below the maximum zoom value we defined. And in the camera zoom out action, check if the camera is still above the minimum zoom value we defined. The minimum and maximum values will ensure the user doesn't get too close or goes too far from the scene. But I still have another trick up my sleeve I haven't shown you yet. We are going to make cool zoom in and zoom out effects with the camera. The goal is to make smooth zooming with a custom transition function. If you are interested, stick around. First, we need a tween to make the smooth zoom and custom transitions. Then, we create a new tween object and call the tween property method with a custom transition. Note that to achieve the camera zoom out, you need to divide the current zoom value by the same factor as the zoom in effect. Here, I am replacing the magic numbers in the code with constant variables. If we try this now, it kind of works, but if I scroll the mouse wheel a lot, the camera zoom doesn't work until I stop. So how do we fix this? Simple. We add a couple of checks to determine whether the tween can be started. If the tween is not valid, or it hasn't started yet, we can start it. And now you have cool zoom in and zoom out effects.